So Sam Altman, the CEO of OpenAI, sits down to talk to Y Combinator's president and CEO, Gary Tan. It's a fascinating discussion. I recommend everybody watch it, but in this video, let me just kind of show you the few things that really jumped out to me. I gotta give credit to Gary Tan here. He is probably one of the best interviewers to interview Sam Altman so far, because he knows what he's talking about. He's not pushing his own agenda, and he's trying to get Sam's opinions on things instead of pushing whatever beliefs he has. And also, they both obviously know quite a bit about scaling these tech companies, these tech startups. So there's certainly a lot in common there. And a big theme of this discussion is just this idea of what happens when machines start thinking. And it's a pretty big question. They note early on Sam Altman's prediction that superintelligence might only be thousands of days away. Thousands. That's pretty wild, and it's a bold claim, and certainly many people are still skeptical about this. But if you look at OpenAI's journey, and it's been a pretty fascinating ride, starting with Sam Altman and Elon Musk, who was one of the original founders of the company, they transformed from a tiny startup, almost a joke to some people in the industry, into the driving force behind so much of what's happening in AI right now. And there's one sort of key theme, this main theme that you'll notice throughout the interview. That's OpenAI's unwavering belief and conviction in their approach, even when pretty much everyone else was doubting them. This, by the way, reminds me of Geoffrey Hinton, sometimes referred to as the godfather of AI, who even earlier kind of held the same unwavering belief and conviction when everybody was doubting it. In his case, he believed in neural nets as being one of the keys to kind of unlocking artificial intelligence. For many decades, while most people in the industry, the researchers working on AI, thought that this was a dead end, he stuck with his belief and, well, is one of the reasons he's referred to as the godfather of AI right now. So when OpenAI was just starting, some of the other sort of AI experts, people in the industry, would refer to them as irresponsible young kids, according to Sam Altman, as if they were just like messing around with something they didn't really understand. This was because they, from the beginning, specified that their approach, what they were trying to do, was to build AGI, artificial general intelligence. So a machine with the same sort of intelligence and abilities as of the average human, so to speak. We don't have a really nailed down definition of what AGI is, but OpenAI, for example, defines it as kind of reaching a point where artificial intelligence can do most of the economically viable tasks that humans can do. Now, when they were starting out and talking about building AGI, the AI landscape was very different. ImageNet had just come out, and it was impressive for image recognition. This AI was mostly about, and most of the other AIs that are available, they were mostly about classifying things. Could it tell a cat from a dog, for example? Now, OpenAI was looking way beyond that. They were betting big on deep learning and scaling up on compute power. That was their path to something truly groundbreaking. Now, a lot of people thought they were crazy for it, pouring that much money and resources into just one approach. It seemed reckless to a lot of people. The conventional wisdom was to diversify, hedge your bets, but OpenAI went all in. You can argue that laser focus is what got them to where they are today. It's like a classic startup story. Take a huge risk, a huge bet, and maybe you fail spectacularly. But if you win big. Speaking of winning big, this interview highlights how crucial the access to all of the computing power was for OpenAI. That's something that startups could only dream of, especially back in the days. And this was another criticism leveled against OpenAI. People saw it as wasteful, throwing all those resources at what seemed like a very long shot. But Altman, looking back, talks about how most people still underestimate the value of that extreme conviction. It's a powerful lesson, really, not just for AI, but for anything. Focusing your energy, not trying to do everything at once, can make all of the difference. It makes you think, even outside of AI, how often do we hold back from really going all in on an idea, even if we believe it deep down? It's human nature to play it safe, but sometimes you need that unwavering faith in your vision, especially when you're trying to do something truly innovative. Interestingly, and kind of unrelated to this, but Peter Thiel, one of the people that became a billionaire in the technological revolution, part of the PayPal mafia. That was one of the things he pointed out, that a lot of the best tech founders happen to be on the spectrum. They might have Asperger's, and they tend to stick to their convictions regardless of what other people think.
One of our strengths is the ability to get punched in the face and get back up and keep going.
They pursue their weird thing that everyone else is telling them they should just forget about. So when they win big. But the point here is that OpenAI had the conviction, they had the computing power, but here's where it gets really interesting. OpenAI did not see large language models like ChatGPT. They didn't see that as the key to AGI, not at the time. They were focused on robotics, game-playing AI, all sorts of things like that. There's this amazing anecdote about Alec Radford, one of the key researchers at OpenAI. And by the way, this person seems kind of like a big deal. He gets referred to as an incredible AI researcher, although I don't know if I've seen too many interviews or even pictures of him. But this person, he was experimenting with Amazon reviews, just kind of playing around, testing things out, and he stumbled on this unsupervised sentiment neuron. So unsupervised sentiment neuron sounds pretty technical. So what is that? Well, basically this neuron in their neural network that was classifying these Amazon reviews, the network was able to understand the sentiment of the review. Was this a positive review for the product or negative? And it was able to do so without being explicitly told how to do it. It just figured it out on its own. It was a tiny detail, almost an accident, but that tiny detail sparked the whole GPT series. It was kind of a foundational discovery for the GPT series. And as you know, GPTs have completely changed the game for AI. By the way, Dr. Jim Fan from NVIDIA has talked about this in other posts that he's made, this idea of that these models, they're not explicitly taught how to do certain things. They learn implicitly. They figure it out on its own. I tend to think of it as, imagine a kid that you tell them a certain thing, like don't do this, don't do that. That's trying to teach them explicitly by telling them. But of course, as you probably are aware, kids also learn implicitly. They observe what you're doing, how you're behaving, how other people are behaving. They make their own sort of judgments about the world around them. They're learning implicitly. And this is what Alex Bradford discovered with this unsupervised sentiment neuron, that it learned implicitly to tell the good review from the bad, the negative from the positive. And it's kind of mind-blowing that this one little thing, this neuron figuring out feelings in Amazon reviews, could lead to something as massive as the architecture that is GPT. Kind of goes to show you never know where that next spark of brilliance will come from. And that little spark led to some pretty seriously disruptive stuff. When GPT-3 was released, while everyone thought it was impressive, it didn't really have these clear business uses that made GPT-4 kind of blow up and rapidly scale, at least on the enterprise side of things. So GPT-3 was more like, look what it can do, cool. Whereas GPT-4 was more like, look what you can do with it. Look what you can build with it. Huge difference. They also mentioned Jake Heller, who used GPT-4 to build a legal tech company, so a tech company for the legal field, that was later acquired for $650 million. It wasn't just about cool demos, it was about real-world impact. And this is where things started to move really, really fast. And that's where we see this shift from level 2 systems. This is as OpenAI sort of explains the levels of AI, right? So level 2 is systems that can reason and solve problems. And so we're beginning the shift from level 2 to level 3. And these are the systems that can function as agents, handling complex tasks. GPT-4 and all the things being built with it are really showcasing that leap. So, by the way, in the interview, Altman describes the sort of 5 levels of AGI. This is kind of a framework put forth by OpenAI to kind of give us an idea of where we are in AI development. So, level 1 is basic AI. Now, we've had this years ago. Level 2 is where things get interesting. AI that can reason, solve problems, understand concepts. Then we have level 3. Like we said, this is the agent level. This is probably highlighted by the O1 model, the latest release. It's able to think through its tasks before acting and seems to have more ability to have these agentic capabilities to complete long-term tasks. And so level 3 is about AI that can not only think, but can act independently, make decisions, complete complex tasks. Imagine a personal assistant, for example, that can not only schedule your appointments, but could also potentially negotiate a better deal on your behalf or even manage your investments based on your personal goals. That's the kind of agency we're talking about. Next, we have level 4, and this is what Altman calls the Innovator, AI that can not only perform basic tasks, but drive innovation, coming up with new ideas, making scientific discoveries, basically pushing the boundaries of human ingenuity. And level 5 is the big one, company scale intelligence, which is essentially AGI that can operate at the level of a large, complex organization. So we're talking about AI that could potentially run a whole company, manage resources, make strategic decisions. That's the idea. But again, this is still very much in the realm of speculation. However, what's interesting is that Altman seems to think we'll reach level 5 sooner than most people expect. And there's actually some evidence to back this up. And it comes from a surprising place, and that is the OpenAI hackathon posted by Y Combinator. At this hackathon, a startup actually used GPT-4 to design an airfoil. So an airfoil, like the wing of an aircraft. This was a functional airfoil that could actually lift and maneuver. So we're not talking about writing marketing copy or summarizing legal documents here. This is AI designing a complex piece of technology, something that would normally take years of specialized engineering expertise. And it really does suggest we might be closer to those Innovator level 4 systems than we realize. It's this kind of rapid progress, the leap from writing code to actually designing physical objects, that has people like Altman and likely Gary Tan feeling pretty optimistic about the timeline for reaching those higher levels of AGI. So hearing about this OpenAI hackathon definitely got me thinking about this Innovator level 4 systems. Seeing GPT-4 being used to actually design a working airfoil, that's a huge leap forward. Kind of makes you wonder what's coming next. What happens when AI can not only perform tasks, but actually start driving innovation in all sorts of fields? We're definitely seeing more and more of that come out of, for example, Google DeepMind with their designer proteins, as well as AI models that are beginning to design computer chips that AI runs on. They talk about some areas where we might see this Innovator level AI really having a big impact. Scientific research, for one, we can use AI to analyze massive data sets, identify patterns that maybe human researchers would miss, coming up with potentially new hypotheses. Imagine, for example, an AI that could sift through mountains of data on climate change and pinpoint the most critical factors or suggest solutions we haven't even thought of. That could be a game changer, especially for those really complex problems that have stumped scientists for decades. And it's not just about analyzing data. AI could also play a role in designing experiments, running simulations, even controlling lab equipment. It's like it becomes a partner in the scientific process. I'm picturing a future where AI isn't just a tool for scientists, but a collaborator, helping to accelerate the pace of discovery and innovation. And it highlights how important it is to be adaptable, to embrace these new technologies and find out ways to work with them, not against them. It seems like the future belongs to those who can adapt to this wave of AI, to learn new skills, to find new ways to integrate AI into their work, their business, their lives in a positive and productive way. And this interview points to the fact that we might be on the verge of a major societal shift. We're entering an era where AI could help us tackle challenges we've always thought too big or too complex to solve. AI could help us unleash new levels of creativity, unlock human potential in ways we can barely even imagine now. Now, of course, with all this excitement and optimism, there are also things like AI safety and ethics that try to mitigate some of the risks from AI. And as we develop these increasingly powerful AI systems, we need to make sure they align with our values and that we have safeguards in place to prevent any unintended consequences. A number of people have left OpenAI that were kind of working in this field. I've recently watched an interview with Miles Brundage, who is an OpenAI researcher specifically working on safety that recently left. And he's not necessarily saying that what OpenAI is doing is sort of bad or unsafe, but he is saying that as a whole, we really need to figure out how to have brakes on AI development. He's saying you wouldn't drive a car without brakes. You wouldn't say, well, let's just kind of accelerate. And then if we see something bad, in front of us, then we'll figure out how to brake this car, meaning how to, push the brakes. He's saying we need to install the brakes now so that when we run into some dangerous territory, we can rapidly decelerate. And he's saying we don't really have that in place now. And of course, we've had some people that are more critical of OpenAI, specifically pointing the finger at them as being more, let's say, profit-driven, more sort of driven by market incentives than first and foremost focusing on AI safety. Anthropic has been seen as kind of like the company that's kind of a sister company to OpenAI, but that has been really focusing on safety a lot more. Recently, they did join forces with Palantir, which is kind of a spy/military/national security company, AI company that works closely with the US government, among other nations. And so a lot of people are they're not sure how to feel about that. Now, besides that sort of airfoil, that OpenAI hackathon did have some other really interesting aha moments that probably made people think like, whoa, the future is closer than we thought. So again, the airfoil, the GPT system was able to iteratively improve on it. So it was basically kept engineering and improving on it, starting from scratch and turning into something that was highly efficient, which certainly seems like something that could be described as that kind of innovator level AI system, maybe some sort of a proto level 4 AI system. But another team at that hackathon used GPT-4 to develop a new encryption algorithm. By the way, I'm not sure if they specified GPT-4. This might have been the O1 model. I'm not 100% sure. I apologize if I missed that detail. They were using OpenAI's models. But one team used it to develop a new encryption algorithm. So we're talking about cybersecurity. And so apparently this algorithm was so complex, so different from anything we've seen before, that even experienced cryptographers were stumped. They could not crack it. The OpenAI model just came up with this thing out of nowhere. And it's kind of unsettling, to be honest. If AI can create encryption that's beyond our ability to break, what does that mean for cybersecurity in the future? If you recall the initial Q-Star leak, one of the rumors swirling around was that this thing could potentially break any known encryptions. Now, that doesn't seem likely looking back at it. That might have been a fake rumor that was spread. But there is this idea that AI, sufficiently advanced AI, could potentially break the entire encryption system by figuring out some shortcut that we don't know about, some math that we didn't get to yet. A lot of the encryption that we have right now kind of relies on the fact that every time, let's say you add a letter or a digit, you add a character, the chance of you guessing that password or that encryption gets exponentially higher, right? So for example, if you have a password that's 7 characters, a brute force attack might crack your password in milliseconds. You have 8 characters, that goes up to 5 hours, a massive jump. You have 9 character, goes up to 5 days. So notice how adding just 1 character increases the amount of time, the complexity, it increases it exponentially, right? So 10 characters 4 months, 11 characters would take 1 decade, and just adding 1 more character, so 12 characters, would take 2 centuries. So as you can see here, even as computers get better and faster and smarter, if we just add 1 character, the complexity massively increases. But there's this sort of idea of P versus NP, that basically says, like, what if there's some way of solving that doesn't require this sort of exponential increase in complexity? A simplified way of thinking about that is like if I asked you to tell me if a number is odd or even, right? So if I start with a 1-letter number, if I start with a 1-character number, like 2, you tell me, well, it's even. But what if I gave you a number that started in the trillions? Well, if it ended in 2, you'd say it's even. So in other words, increasing the number of characters in that number doesn't make it more difficult to crack. It stays the same because we figured out a little shortcut, a little trick. We don't have to look at the whole number. We don't have to do any math around the whole number. We just look at the last character, the last digit. If it's even, the number's even. If it's odd, the number's odd. Now that's very simplistic, but the idea of P versus NP, again, really simplifying this idea here. But what if the computer figures out the sort of trick, but for solving our encryption, our cybersecurity, that would immediately make everything visible? The entire finance system, your bank account, everybody's national security if it's online or connected to the internet in any way. I mean, the world is just not ready for that. We have built a lot of our world economy and way of life on this idea that adding an extra digit makes things much harder to solve. Another great example from the hackathon highlights the positive side of AI, where a team using this GPT architecture to develop a system that can analyze satellite imagery and predict the spread of wildfires. Now, if you live in a place like California, you know that wildfires can be a devastating problem. And if we could actually predict how they're going to move, well, that could save lives. And the system was eerily accurate. It used machine learning to identify patterns in the data, things that human analysts might easily miss. It would take into account wind speed, terrain, vegetation, and make these really precise predictions. So this isn't even AI just helping us do something. It's actually better than us at certain things. Kind of humbling to think about. And there will be tons of other areas where this would be very applicable, where this predictive power could be useful, predicting natural disasters, managing traffic, maybe even forecasting disease outbreaks. This is opening up a whole new era of problem solving, of scientific discovery. Now, at the same time, there's an article on theinformation.com that's talking about how maybe the next generation of OpenAI models might be slowing down, that maybe we've reached sort of like the peak of progress. And now we'll get incremental gains. We'll make incremental gains, but maybe not these exponential leaps forward. So some people are suggesting that maybe Sam Altman is trying to hype things up and that the reality is very different. Time will tell. However, it's important to note that the scientists and the other researchers and developers, some that are at OpenAI, some that have left OpenAI, so kind of regardless of their affiliation, they are certainly more aligned with what Sam Altman's saying. The people leaving OpenAI aren't saying that, well, this AI progress is over, so we can just chill. I haven't yet heard one person say that. Most of them are saying this thing is coming fast, it's accelerating fast, and we need to start thinking more deeply about how we're going to handle it. So if this is hype, and that means these AI safety researchers are also hyping it up, they don't really have an incentive to, it seems. So again, I'm not 100% sure where this is going to go. Time will tell, but certainly the people running these things, Microsoft and Google, etc., are investing more and more money and time into not just compute and hardware. They're also, in the case of Microsoft, for example, powering up an old nuclear power plant on 3 Mile Island to develop more electricity for training and running these models. So one way of looking at it is we haven't even begun to scale this thing up yet. But let me know what you think in the comments. If you made it this far, I appreciate you watching. Consider subscribing, hit the thumbs up, and I'll see you in the next one.